Okay, so we have some basics here with trig functions. So we have y equals a times the sine of b times x minus c, all of that plus d. A, the absolute value, that's the amplitude. That's the distance from the midline to the maximum or minimum. Just basically the amplitude is the distance from the midline to the top of the graph or to the bottom of the graph. The period is 2 pi divided by b, and b is whatever you are multiplying x by. And phase shift, the horizontal shift, is c. If it says x minus c, that means you move c units to the right. If it says x plus c, that means you move c units to the left. And the vertical shift is d. We've seen these types of transformations before, and it's the same for cosine, except for the basic cosine function. It starts a little bit differently. Tangent, its period is pi over b. Now, why is that? Well, let's take a look at sine and cosine, the parent functions. So if you take a look at sine, we have 5 basic values. It starts at 0, 0. Then its next ordered pair is pi over 2 and 1. And then at pi, it's 0. At 3 pi over 2, it's negative 1. And at 2 pi, it's back at 0. Cosine starts at 1. So at 0, its y value is 1. At pi over 2, it's 0. At pi, it's negative 1. At 3 pi over 2, it's back to 0. And at 2 pi, it's back up at 1. Okay, so sine starts at its midline, cosine starts at its maximum. Okay, and tangent is actually takes about half the width of sine or cosine. That's why its period is pi over b. And it has, basically it's an odd function as you take a look at it. And it has 2 vertical asymptotes, one at pi over 2 and one at 3 pi over 2. And in between, at pi, it's at 0. At 3 pi over 4, it's at negative 1. And at 5 pi over 4, it's at 1, as you can see in the picture. Or we could go from negative pi over 2 to pi over 2 for the asymptotes. And at negative pi over 4, it's at negative 1. At 0, it's 0. And at pi over 4, it's at positive 1. Those are the basic types of functions. So the first example in first practice is to take a look at a graph and find its amplitude, period, and midline. And so with our first example on the left, easiest to find the midline, just look at what splits it evenly from in between the top and the bottom. And so that kind of looks like there, so that midline looks like it's at y equals 3, so it had a vertical shift of plus 3. The period, well, it looks like it hits all of its values. It looks like it's a basic sine starting at its midline, going up to its maximum, coming back down to the midline, going to its minimum, and then reaching back at the midline. So that goes from 0 to 6 point something. That kind of looks like 0 to 2 pi. Okay, so its period is 2 pi. Amplitude, how far is it from the midline to the max? Well, that's a distance of 1, so it has an amplitude of 1. Second one, same thing, midline looks like about there, and that's again y equals 3. Its period, well, let's see, if I start from 0, it looks more like a cosine function, starting at its maximum, ending at its maximum. That's a distance of 2. And then amplitude from the midline to the max looks like about 3 units, so it's an amplitude of 3. Now I'd like you to try practice 1 on your own, and then check your answers with me. Okay, moving on, example 2, we're looking at, we have some graphs. What could the functions be that produced them? So we've got sine, cosine, or tangent. The one on the left, well, that definitely looks like tangent because it's got those asymptotes. Okay, so tangent, but it's kind of reversed. So that means it kind of reflected. So that's a negative tangent. And then couple values, it looks like we're hitting at 2 and negative 2. That means we kind of stretched it vertically instead of hitting at 1 and negative 1, so negative 2 tangent of theta. The one on the right, well, if I'm starting at 0 for the x, it kind of looks like a cosine function. And then it looks like the basic cosine function just shifted up 1. So that's just cosine of theta plus 1. Okay. Now go ahead and try practice 2, come up with the equations. You can kind of tell right now neither one of those is a tangent, so we're either dealing with sine or cosine. And go from there. Don't forget to check your answers with me. Now the last type, example 3, kind of going through the whole thing, we want to know which functions are exactly the same. We've got a set of 4 different pairs, and on this slide we only see 2, on the next slide we'll only see 2. So I don't graph the whole thing, I just graph pieces of it. So basic function, negative pi to 2 pi for the graph, negative 2 to 2 for the y. And I'm just going to look at 2 sine of x for a moment. And as I look at it, 2 sine of x, well, at 0 it would be 0. And that times by 2 stretches it vertically, so instead of at pi over 2 being at 1, it'll be at 2. At pi, it'll still be 0, but at 3 pi over 2, it'll stretch down to negative 2, and then back at 0. Now, 2 cosine of x, well, that starts at its maximum at 0, and then comes down to, so it's at 2, 0, 2 is the first point, and then at pi over 2 it's at 0, and then at pi it's at negative 2. And the other pieces that we've got, the negative pi over 4 and the negative 3 pi over 4, what that's going to do is just shift them down pi over 4 and 3 pi over 4, which those two are not going to line up. So here's what shifting down looks like. And no, they're not going to be the same. They're not going to coincide. The next two do the same thing, except that in parentheses, that plus pi over 4 for the first one, that shifts it left by pi over 4. So instead of starting at 0, 0, it's going to start at negative pi over 4, 0. And then it'll look like that basic function that we had. So notice it started at negative pi over 4, 0, and then go over 2 quarters. So at pi over 4, it's going to be up at 2. Then at 3 pi over 4, it's at 0. And then at 5 pi over 4, it's at negative 2. And then 7 pi over 4, it's back at 0. And then that minus pi will just take it and move it down pi units. So that doesn't really affect it. But the next part, 2 cosine of x plus 3 pi over 4, well, that goes left by 3 pi over 4. So as you take a look at this, it's starting at negative 3 pi over 4 and up at 2. Goes over 2 marks, comes down to 0, goes over 2 marks, goes down to negative 2, goes over 2 marks, comes back up to 0, goes over 2 marks, and is at 2 again. Now if I take both of those and shift them down pi units, they're still not going to coincide. So no, they're not the same. Okay? Make sure you've got these, and then go to the next slide with the last couple pairs. So these two, instead of moving left, they move right pi over 4 and 3 pi over 4. But there's a second change on the g of x. It's also reflecting the cosine across the x-axis. So right pi over 4, and then still the 2, and then I would just take the whole thing and shift it down pi. The g of x, instead of starting at positive 2, it's going to start at negative 2 at 3 pi over 4, and then go up, and then up to 2, then back down to 0. And no matter how I shift those, they're not going to coincide. Okay? But if you take a look, thinking about this, what if I took that blue one and reflected it back, in other words, made it positive? They'd be starting at 3 pi over 4, they'd both be starting at their maximum. That's kind of what you see in the last one. So those, the third pair, no, not the same. Last one, again, there's 2 sine of x minus pi over 4. I haven't moved it down pi over 4 at all. I haven't shifted it vertically. And then the 2 cosine of x minus 3 pi over 4. Notice that just coincides. And if I take both of those and shift them down by pi, they'll match up. So yes, these two are the same. That's how you have to tell if two functions are the same. And you can also take a look if they shifted the same amount vertically. We can figure that out. And we had to do a horizontal shift to get them to be starting at the same maximum. Okay? Now check off your notes with me and then go try the diagnostic. And if you've got both of those, then try the assessment.